Yes.
Okay.
Oh, homework, sorry, I didn't get all the way back there, did I? Sorry, when the first person in the row is halfway back. Okay, now do I have all the homeworks? Perfect, okay. 1-6 notes are actually kind of funny. So we started 1-6 a little bit at the beginning of last class. I think we maybe did like 1A. We're gonna do all of the 1-6 that's handwritten. And then if you notice, there's one side of 1-7, and then I just have like an extra random page that says more 1-6 practice. That is just more of these types of problems because I think it's helpful to just have as many as possible. So we're gonna jump that 1-7 page and keep going on this 1-6 practice. We did not get through all of the problems in my last period, but hopefully we get through enough. If we need to on this 1-7 / wrap up day, we can do more of those problems together. So don't panic if we didn't get through all of them and you want to see more of them, okay? Let me clear these off. For those of you who weren't here last class, we were doing transformations, which we have been doing before, so this shouldn't be completely brand new information. And I don't think I recorded. Did I record C period? I don't know. Now I'm tripping. I don't think I did. But what I do want to kind of remind you of, if you weren't here, I did review everything with C period because we had a lot of kids absent the other day. This is what I wrote at the top of the page. We did this back in 1.3 when we were just moving our BFFs up and down and left and right. I wanted to rewrite it again because I wanted us to really look at the A is going to be new and interesting this time. B, we're going to do a tiny bit with the B's, but we're not going to do a lot with B's. I really saved B's for when we get into sine and cosine graphing. So I want us to really feel confident about the left and right, the up and down, and then the vertical stretches. I think I wrote this with you guys yesterday, but in case I didn't, remember that whatever your A value is, whether it's 1/2, whether it's 2, whether it's 5, 6, I don't care what it is, you're going to multiply that by your Y's. The stretch happens when we're doing a whole number, and the shrink happens when you have a fraction. The negative just makes it flip. If I have anything being multiplied on the inside, I maybe have 1 or 2 problems like that today. I think I have a negative. That also flips it, but instead of flipping it, like when we flip, we think up and down, like over the x-axis. If I have a negative inside with my x where that B spot is, it's going to flip it left and right, essentially over the y-axis. So instead of flipping up and down over the x, we're going to flip left and right over the y if there's something inside with that x. Also, everything inside with the x kind of does opposite of what you think it should. I don't think we do too much more with that today, so I'm just going to let that one be for right now. I'll keep that up, but I also want to preview number letter A, the first one we did. We took the original graph, just a reminder, if you were here, if you were not here, something good to know. We took the original graph and we made a t-table of all those values. And then on letter A, I think we did that one all together. And I took 2 as my A, that was the number out front, and I multiplied that by all my Y's. If it is helpful to you, do the t-tables. If it is not helpful to you, don't do the t-tables. You can take all of them and just multiply them in your head. I'm just trying to give you tools, and this is on you to figure out what works for you, what are you successful with. Okay, anybody questions on 1A? Is that the only one we did yesterday? Yeah? No? Yeah, okay, sorry. Okay, now we're gonna get to 1B, which my other class did, I'll erase it. This time, again, you can do this differently, but I'm gonna do my t-table. This time I've got that +1, which means I'm gonna go to the left 1 unit. What that means is I'm gonna take x and go -1 from it. Again, we're doing opposite of what we think we should. So I know it says plus, we're gonna -1 from all of our x's to show that I'm going to the left 1 for my x's. There's no y changes because I don't have anything out front or anything being added or subtracted to the end, so my y's don't change. What I'm gonna do is I'm gonna take my t-table and I'm just gonna copy and paste it. If I had to like physically handwrite it, I would physically go rewrite it, but I have notability magic, so I'm just gonna copy and paste like that. And now I'm just gonna add or -1 from all my x's. Another thing you could do is you could just plot your original points and then just move them all to the left 1 unit. That is an okay thing to do. Again, lots of different options on what you want to do. That is a hard thing for me to teach you to do, to be like, hey, take all the points and just move them left one, so I'm gonna do my T-table, but you are welcome to do that. Okay, so I'm gonna -1 from all of these. Oop, that's not what I wanted. -1 is -3, -2, -1, 0, 1, 2, 3. My Y's didn't change, so I'm gonna go draw my coordinate plane, and I'm gonna graph these. Is everybody okay with what I've done so far? So -3, -3, -2, 0, -1, 1, 0, 0, 1, -2, 2, 0, 3, up to 2. Once I fix my T-tables, once I adjust it, once I graph it, I go back to look at my original graph, and it should look like I just moved it to the left 1 unit. This is my duh check. Does it look like how it started? Just kind of my like, don't make a dumb mistake kind of check. Like, does this kind of look like the graph that I started with? It does kind of look like the graph I started with. It just looks a little shifted over, okay? You will do some transformations that might make it look a little crazy, but nothing should make it look not at all like how you started. So that's kind of your like, am I doing this right check? Does this at least look a little bit like how I started? Everybody good with that? All right, flip your paper over. Now we're gonna do negative f of x. What is that gonna do to my graph? Flip it over the x-axis. So you can just take all the points and just flip them over the x-axis, or I can think about I am doing that negative times my f of x. I'm doing -1 times all my y's. So I'm just gonna change all the signs of my y's and make them negative if they were positive, make them positive if they were negative. So the first one was -3, so I'm gonna make it +3. The zeros stay, my +1 becomes negative, that -2 becomes positive, and then that +2 becomes negative. And I can rewrite my zeros next to it if that makes me happy. Notice that there's nothing inside with the x, so I don't add, subtract, or multiply anything to my x's. The only thing that changed was my y's. Once I have those points written down, I'm going to graph all the points that I have. And again, if you don't like the T-table, don't use it. Just take the points and just flip it over the x-axis. I was mad. I really like Father, but he has just like a preaching voice. He is just like projecting at all times. And I love when he gets animated like that. But we're just like having a really chill, like scrapping our little points. And he's like, you do not divide by 0. Oh, he's funny. That's a funny man. -0, 2, 2, 3, 0, 4, -2. Good enough. Does this kind of look like our other graph just flipped? Yeah. Questions, thoughts, comments? All right, the last one we're gonna look at with this one graph, this one set of points that we've been using. This next one, letter D, says absolute value of f of x. Is that absolute value outside of the parentheses or inside the parentheses? It's outside the parentheses, so what are we doing that to, our x's or our y's? Our y's. We're gonna do the absolute value of all of our y's. If it's already positive, you just keep it as is. The only thing that changes is if we had a -1, it just pops up above the axis, okay? This is kind of a funny one to think about, so let's just get our points. Again, if you do not like using the t-table, I'm not gonna make you, but what I would think about if I was you, oh, I lied, there's two more with this, so sorry. So hopefully we'll get both of those in. If I have this f of absolute value of f of x, we are just gonna absolute value all of my y's. So my y's that were negative become positive and everything else stays the same. Essentially think about it like the graph is exactly the same, but instead of being on the negative y's, it just has to flip up to be the positive y's. The only thing that flips is what was already negative. If it was positive, it's fine as it is. So that first point, instead of being at -2, -3, it's gonna be up at -2, +3. My next few points are all normal, they're the normal points. And instead of +2, -2, we're gonna go +2, +2. And then all my other points are the same. So this actually is a picture that does not necessarily look like how we started. How I started was something like this. But do you notice that the parts that were positives just stay the same? And then the parts that were negative get flipped up. So any part that was negative now flips up to be the positive part. All we did was take absolute value of all of my y's. The actual last one, sorry, I lied and said that the last one was a minute ago. The actual last one now has the absolute value inside the parentheses. So what should I be doing absolute value of now? The x's. So let's carry our points over because this is going to be a little bit different. Okay. Now, we're not going to treat it exactly like we treated the other one. This time, I want you to graph your positive x's, right? If we do the absolute value of an x and it's positive, does that change what my answer is going to be? No. So the positive, so 0 and anything positive are fine points to graph. So let's just go graph those first. All of my positive ones are fine. I'm not worried about that. Now, what happens when I absolute value my x? See that the absolute value is inside of the function. So basically we're taking the absolute value before we do the function. When I plug in -1, it's going to be like I plugged in +1. So I want my y values for all of the negative x's to match the y values of all the positive x's. Okay, so essentially we're going to mirror over the y-axis. We're going to take all of the positive x's and we're going to mirror them over the y-axis. I'm going to take all of these points that I just drew and I'm going to mirror it over, okay? Now, if you look at our t-table, -1 is like I plugged in +1, right? Don't they have the same y's? They both have zeros as my y's. However, when I go to do -2, -2, when I do the absolute value of that, that's like plugging in +2. So instead of getting out -3, I should get out -2. I'm doing the absolute value of that -2 before I'm putting it into my function. So when I do the absolute value, it's the same as just having plugged in 2. I also know I don't, sorry, what? I'm fully aware. Now I have 20 seconds, so I'm reflecting it all over to the other side. That even though I don't have a -3 on my x's, I still am gonna go take that +3 value and graph it where the -3 is. So I'm gonna graph +3, 0 and -3, 0. And then last, I'm gonna graph that 4 as -4, 2. Okay. When we do the absolute values, it's a reflection of the positive x's over the y-axis. We're going to do at least 1 or 2 more of these after lunch, but I wanted you to see it before lunch. Questions? Go to lunch. You have to be back by 12:30. That's when I'm teaching more stuff. Yeah. Yeah.